This is Devika, and today we are looking at sequences. So if you have not subscribed to Devika Academy, kindly subscribe so that every time I post a notification, you are in tutorial, you are the first to get the notification. Okay, today we are looking at sequences. So let's know the definition of sequences. This is function whose domain is set n and the range is n subset n. If the range of the sequence is a subset of a real set, then the sequence will be known as real sequence. So if you find that the range is given by real set, a subset of real set, then you know that is a real sequence. That is, if you have this function here, so this is the function that you are calling the sequence, so that n is the domain, this is the domain, and this is now the range. So if it happens this one, it happens, then this is basically a real sequence. It's a real sequence. Why are we saying that? It's because the domain of this sequence is set n, and the sequence is fully determined if we know a given function or n such that it gives us a x which depends on n. Remember, this is 4 members of n. In this case, n is the domain. There's different ways of describing a sequence, and the first one is by listing in a suggestion in a few terms till you get a definite rule. For example, if you take this, if you look at it keenly, you'll find that you can see that the nth term can be described as 1 of n. So that's one way of doing it. You list until you see a term that can give you a definite rule that you can apply all over to the nth term. Secondly, is specifying the rule of nth term. So in this case, now you do the reverse of a, whereby we have this. That means if you substitute the values of n, starting with 1, and for n equal to 1, and so on, you'll be able to come up with a sequence. Thirdly, you can use what you call recursion formula. And this is a sequence which can be described by specifying the first few elements as in A and a row of terms or preceding terms. So you have a preceding terms. You have first one and the preceding term. So for example, if you have a sequence here given like this, which means in this case they are produced by xn, and you are given x1 to be that, and then x plus 1 being given by this, it will imply that in every time, so x1 is already here, so if you want to get x2, we'll get it when x is equal to 1. Okay, when x is equal to 1, so you can see it will be root 7 plus, so in this case n is 1, so you can see it is x1, so it will be root 7, or that way. So that way substituting, so this x naught here, you can see here now we are talking about x being equal to 1, and which is this x that, so you substitute here. So by doing that, you are applying the idea of recursion formula, So in this case, let x1, x2 be a positive real set, so that x plus xn plus 1 term will be given by this. Remember, this is for n greater than 1, n greater than 2, and in this case you'll find that each term can be fully determined. So xn in terms of x1 and x2 and recursion formula, you'll get the relationship that we have just seen above here. So you can just substitute and play with it, and you see that you can get a general way of defining the terms in the sequence. So those are many ways that we normally use to identify the sequence or to define a sequence. Remember, if you have not subscribed to this channel, kindly subscribe. Click down there, there is a button for subscribing. So subscribe, and remember also to share with your friends. This is an introduction course to introduction to zero analysis. So if you have these facts, you get these facts correctly, then you will not find any problem while doing zero analysis. Okay, equality sequence, equality of sequence. When do we say that a sequence is equal to the other? Two sequences xn and yn are said to be equal if and only if xn is equal to yn. So if you find those sequences as equal, that's the only time we'll say that the two sequences are equal. So if that happens, then you say that two sequences are equal. What about range of sequence? The range of a sequence xn is a set of 4 values which can be divided by xn for n in n, consisting of distinct terms without repetition. And again, it doesn't matter whether they are in position, irrespective of their position. So if they are not repeating themselves and you have gotten all the xn such that n is a member of n, you'll find that what you get there is a range of sequences, the range of the sequence. For example, if you have a range, we want to determine the range of xn, whereby xn is given by this. When n is equal to 0, okay, n is equal to 1, you see that you'll get that first term. Okay, if x is equal to 2, then you can see we're having that. If you do xn being 3, then you see we are getting that, and it repeats like that. But we are talking about distinct, no repetition. So it will mean that the range of this xn is actually and that. So that is the range of that the set that we have, the sequence that we have in this. Now let's look at another sequence we call constant sequence. Constant sequence. So a sequence xn, where each element in xn is c or is a constant, then we'll call that sequence a constant sequence. We'll call it a sequence. Each element being in xn being a constant, then you see that is a constant sequence. That one will be a constant sequence. If you have any question on either of these remarks, kindly leave a comment. If you have a question also in the list that you need us to look at, you can leave it like a comment. We'll be able to check on it. Okay, so if you have not yet subscribed to this, kindly subscribe, and if you have subscribed, remember to share with your friends so that they get this information. Okay, that's until next time.